Have you ever watched an AI play a game like chess or Go and just wondered how? How does it make these moves that are so creative, so inhumanly smart? Well, the answer is this incredible idea called reinforcement learning. And today, we're going to pull back the curtain and see exactly how it works. Right, so this is the big question. We see these machines beating the best players in the world at the most complicated games we've ever invented. How on earth do they learn to do that? Well, here's the secret. And it's not what you might think. It's not about feeding it a giant rule book or having it memorize every grandmaster game in history. Nope. The secret is learning through pure, raw experience, just by playing. And that idea, learning by doing, brings us to our first major concept. This is all about learning without a teacher, without a supervisor. It's not about someone giving you the answers, it's about figuring them out for yourself. Okay, so what is reinforcement learning, officially? At its heart, it's a way for a machine to learn how to reach a goal, simply by interacting with its world. You can think of it like, well, like any game, really. You've got a goal to win, and you learn the best way to get there by just playing. The absolute best analogy is training a dog. You can't sit down and explain the physics of fetch, right? Of course not. You use rewards, a treat, a good boy, a pat on the head. You reinforce the behaviors you want to see. And that is the absolute core of RL, learning through trial and error, all guided by rewards. So how does this actually work inside a computer? What's the structure? Let's pop the hood and look at the agent's game plan. Everything in RL boils down to this fundamental loop. It starts with our learner, which we call the agent. First, the agent looks around and observes its state, its current situation. Based on that, it chooses an action. Then, the world, or the environment, responds. It gives the agent a reward, which could be positive or negative, and a new state. And this cycle just repeats, over and over and over, sometimes millions or even billions of times. With each loop, the agent gets a little bit smarter about which actions lead to the best rewards. But here's where it gets really, really cool. It's not just about grabbing the closest, most obvious reward. It's about learning to play the long game. And this distinction is absolutely critical. A reward is that immediate feedback. It's the little burst of satisfaction you get from a good move. But value is about the long-term potential. See, a move in chess might not give you an immediate reward, but if it sets you up for a checkmate 10 moves down the line, its value is huge. The smartest agents learn to maximize that long-term value, not just the short-term reward. This whole idea of learning long-term value has a really fascinating history, and it's the key that unlocked RL's ability to go from simple games to tackling some incredibly complex real-world problems. I mean, think about a super simple game like tic-tac-toe. An RL agent would start out playing completely randomly, just putting X's and O's anywhere. But every time it accidentally wins, it makes a little mental note about which moves led to that win. After thousands and thousands of games, it slowly builds up an unbeatable strategy, all by itself. And you know what's crazy? This idea is not new. It goes way back. In 1911, a psychologist named Edward Thorndike basically described the core principle of reinforcement learning with his law of effect. It's this fundamental truth about how we learn: animals, humans, and now algorithms. The real breakthrough for computers, the thing that made it all click, was this idea called temporal difference learning, or TD learning for short. This lets an agent learn at every single step of the process, not just when the game is over. It's always updating its strategy by comparing what it thought was going to happen with what actually happened. It's learning on the fly. And people put this into action pretty early on. Way back in the 50s, a guy named Arthur Samuel built a checkers program that eventually learned to beat him. But the moment that really put RL on the map came in the 90s, thanks to Jerry Tesoro. Tesoro created something called TD Gammon. It was an AI that started with literally zero knowledge of how to play backgammon. By playing millions of games against a copy of itself, it taught itself to be one of the best players on the planet. It even came up with brand new strategies that human experts had never seen before. This was a massive, massive moment. Now check this out, because this is a perfect example of how RL can solve really tricky, non-obvious problems. In this thing called the mountain car problem, the car is too weak to drive straight up the big hill to the goal. The only way to win is to actually reverse first, go up the other hill to build momentum, and then gun it. An RL agent figures this out by building a value landscape, where it learns that sometimes moving away from the goal actually has a higher long-term value. How cool is that? And RL isn't just for games and physics puzzles. It's being used all over the place to optimize incredibly complex systems. Things like dispatching elevators in a skyscraper, managing your cell phone network, scheduling tasks in a factory, and even controlling complex robots. But as powerful as all this sounds, it's not a magic wand. It's really important to do a little reality check and understand its limits. Okay, so first off, RL needs a ton of experience to learn. We're talking millions, sometimes billions of attempts. Second, figuring out the right reward to give the agent is actually super hard. If you get it wrong, the AI learns to do something totally unexpected. And finally, it really works best when the problem is clear and the agent can perfectly see its state. So after all of that, if there's just one thing you remember from this, what should it be? Here it is. At its core, reinforcement learning is simply the science of making the best possible decisions over time. It's a universal framework for learning how to achieve a long-term goal. And that kind of leaves us with a huge question for the future, right? We're building systems that can learn to think long-term, to make choices that aren't just good for right now, but for the future. As these agents get smarter and more capable, the real question isn't if they'll reshape our world, but how.